All right, welcome back to our discussion on data visualization. We started off with pandas plotting, then we talked about seaborn plotting, generating charts and graphs, and now we are discussing towards the end of our discussion now, but we are now talking about the pillow library to operate on images. And by that, we also include images generated by pandas seaborn as well as images captured by your mobile phone and webcam and various other sources like web, blog sites, server, cloud, and so on. So anything that is an image can be processed. So we have learned a lot about the pillow library. We are able to annotate it down, slice it, dice it, crop it, enlarge it, modify it, filter it, enhance it, find edges, and so on, so forth. And now at this sort of last part of our discussion, we like to compose new images with the idea that I want to piece up together the graphs and charts generated by pandas and seaborn. Okay, maybe also with a added image captured on the street scene, just to give it a bit of realism, right? So how do I do that? First of all, import everything, right? So we have numpy pandas matplotlib pyplot to generate the chart. So I'm starting from scratch, total emptiness, only the data frame. Okay, so I only have data, no image to begin with, nothing. So all these are after the processing. So I initially don't have any of these. I only have the data. So the data is something I type in here. Remember in our pandas data frame discussion, the data could have been downloaded from internet, passed to you as an Excel file, HTML file, text file, CSV file. You can just read it in and it becomes DF. Yeah. So from this point on, basically to Python internally it's just a DF. What we do is we want to plot A as a histogram, which is this blue chart here, and then we save it. So the mechanism to do is save as a temporary file and then use image library to read back in the file as a JPEG file, PNG file. Now, if you're doing charts, I would strongly recommend you to save your temporary files as PNG because the JPEG, no matter how high a quality, when you zoom in, there may be a bit of aliasing. So at the edge here, the blue-white is not a distinct blue-white, but white, slight blue, very blue, then full blue. So there's a bit of aliasing going on that will make your image increasingly fuzzy if you save load in JPEG. So what you do is for graphs and charts, you need that very clear, distinct boundary to make it sharp and nice, right? So try to keep it as a PNG file, okay? Save fig, right? This part is something we have done many times. Save fig into the subdirectory picture. That's because of my setup. You don't really need this if you don't want to. Plot, any temp name is fine. Then we also generate another pie chart. So it's very distinguishable as another file. So right now there are two files. One is histogram, one is pie chart. But we really want it to be a single file so that, you know what, when we send attachment, it's just one attachment. When we put it in our presentation, we know the orientation and positioning have been fixed. It will not be two files, just moved around by the editor, right? So how do we do that? Automatically use the pillow library, all right, to import, to open. So when we open, we definitely get back the images. We get image 1 and 2. And then what we want to do is we can create a sort of resized image while keeping the aspect ratio. So we shouldn't be using dot resize. We should be using thumbnail. But remember, thumbnail modifies the image directly. Very strange, but because dot resize doesn't, it returns a new copy. So it doesn't matter. We make a copy ourselves, right? And then we say the 1c dot thumbnail no larger than 500, 300. So we do expect it not to occupy 500 or else 300. So we better check the size of the returned image. So this is the width height, right? It may also not follow exactly 500 nor 300, both of them. So we have 2C is a copy of image 2. 2C is a thumbnail no larger than 500, 300. Same thing, we get back the width and height. Although they were generated together, they have the same data width and data rows, they may not be of the same size, right? So definitely allow the flexibility that 1C has different height from 2C. Keep that flexibility going. Then what I want to do is introduce this put alpha. Okay, when I put in this put alpha, the put alpha allows me to insert a layer. So if we remember if we remember originally in our discussion about this 3-layer color planes to form the final colors that we see. When I say put alpha, Pillow will insert one more layer. So there will be 4 layers instead of 3 layers. So much more memory intensive. And the 4th layer is called the alpha channel. That's why it's called put alpha. The alpha channel determines the transparency. So if it's 0, it's opaque. Cannot see through, right? So if it's 255, then it is solid. Sorry, opaque as in you want these 3 layers to be shown fully. And if it's 0, then 0 times any of these values becomes 0. So it's not being shown through. So when we say put alpha, we are creating a channel that is initially 50% transparent, 1 to 8. Okay, 50% transparent. If you put 100% transparent, 255, then it's transparent, see-through, right? So it's not going to be visible. So we want that. Then we say image new RGBA, because now our images will be having the alpha layer. So RGBA of size 1040 by 320 of this background color, which is a bit reddish, but not full red. Okay. Then we paste. We paste onto it image 1C and image 2C. So image 1C, image 2C. Now, notice that I'm putting the C version, the thumbnail version, the copied version, rather than the original. So this image 2.put alpha actually will not end up being shown in our image 3, because ultimately we only show image 3, right? So I'm just taking the opportunity to show you how we may, after the fact, like we have created RGB, how do I actually insert a transparency layer? Just put alpha and that will insert in a new layer. Then finally, we want to annotate it, right? So we have already pasted. I think this part of the calculation I've shown and discussed before by looking at the width, the allocated space minus your width. Then we have a thick border and we cut it into half so that one half is on the left, one half is on the right. We create the border. So all these calculations are pretty standard. And finally, we want to insert a sort of common title, because in the ax.set title earlier on in pandas, that is for each axis, right? Each graph, each chart. But now that we are composing a new chart, new graph, we better draw our own. So using the drawable that we created earlier on, we are going to drawable onto image 3, create a font, and text it onto here using a color that is kind of a purplish color. And that's all. As simple as that. Now, of course, when we show it and then switch off or exit the program, then this is gone. How do you get a version that you can email out to your friends and boss? Save, right? So in this case, just simply image and dot save. And because this is image, this is no longer under pandas or Seaborn. So just save it with a new file name like JPEG, because this is the end product. You're not going to modify from here anymore. So save it as a JPEG file to obtain size efficiency, and then you can attach into your email and send out. So end of program, very simple, right? Because every part is a one-liner. Every part is doing its own very, very heavy, intensive role. And we just need to summon all these instructions together and get the job done. So this is efficiency and productivity. Definitely try to exercise on this and then become very proficient in all these image processing stuff. See you in the next video.